This video is a tutorial on processing 16S ribosomal RNA gene amplicons, and specifically V4 amplicons sequence data returned by MSU's RTSF sequencing facility. RTSF uses a method developed by Qiime et al., described in this paper, and the Illumina MiSeq platform to produce the sequences. Processing these sequences is relatively simple because they've already been binned by sample, separated into forward and reverse reads, and trimmed of primers and adapters. This tutorial is meant to be run on your own computer. It could be Windows, Mac, or Linux. But that means you have to have certain programs installed on your computer first. FastQC, MultiQC, Figaro, and Qiime2. If you have a Windows computer, I suggest that you first install WSL2 with the Ubuntu version of Linux. Then you can follow further instructions for installing Linux versions of the programs. If you have a Mac computer, a common problem is that the utility wget is not already installed. You can install it with Homebrew, but Homebrew is not already installed. So you should first install Homebrew and then install wget. If you need to install WSL2 on your Windows computer, you can search for it like this. This will probably be the first page you're taken to. Just click on that. You can see the URL here. And if you scroll down a little ways, you'll see that it's very simple to do these days. You just open a PowerShell terminal and enter this command. You can even just copy the command to the clipboard and paste it into the terminal. Execute it and you're done. If you don't have the wget utility on your Mac, you can go to brew.sh, which takes you to the Homebrew page. You can install Homebrew just by pasting this command into your terminal and running it. And then after it's finished, you can install wget by typing brew install wget into your terminal. Now you may need to close your terminal and reopen it before you install wget. But that's all there is to it. Once you have WSL2 on your Windows computer or wget on your Mac computer, you can install the other programs you will need with Conda. Conda is a package and virtual environment manager included in the Python distributions Anaconda and Miniconda. If you've not already installed either of these, I recommend Miniconda 3. To install it, open a terminal on your computer and then follow the instructions on this page of my website. After you have Conda installed, then you can start creating environments. The first one is one for the FastQC program. Depending on how you have installed Conda, you may need to run this line to make Conda available. Once it is, then you can create the FastQC environment with this line. So Conda create -n is the name of the you want to give the environment. -c bioconda is a repository from which to download the programs, and the two programs you'll install are FastQC and MultiQC. We will use Qiime2 to process our sequences. The Qiime2 program is updated 2 or 3 times a year. To get the latest version, follow the directions on this slide. Go to qiime2.org, click on Qt-CLI, and then installing Qiime2. That will present instructions for installing Qiime2 for your operating system. Remember, if you're using Windows with WSL2, you'll be installing the Linux version. Also, beginning in September 2023, there are Amplicon and WGS versions of Qiime2. Be sure to choose the Amplicon version for this tutorial. Next, I want you to install Figaro. Figaro is a program that takes the guesswork out of determining truncation parameters to use with the .i2 plugin we will use in Qiime2. I have recently updated the instructions for installing Figaro on my website. So if you go to this URL and follow the instructions, you should be fine. The general steps are to first create a Figaro-compatible environment using Conda, then download and install Figaro. This page also presents what method for testing your installation. Let me know if you encounter any problems. Okay, so we are done with installing things. Our next step is to download some data to process. There's a URL in the description below for the data for this tutorial. If you enter that URL in your browser, you should be taken to a page that looks like this. Just click on the download link to download the data. In my case, the file went to my downloads folder. Next, I need to move it to my home directory. So I can just copy the file, and since I'm using a Windows machine with WSL2 installed, I need to put it into my Linux home directory. So Linux, Ubuntu, Home, and then my ID. Just paste it here. Now if you're using a Mac, you just put it in your regular home directory. So next I need to open my Ubuntu terminal. Click here. Click on Ubuntu. So if I list all of my tar.gz files, I see that I have the one I just downloaded. I can extract it with tar xzf and then the name of the file. I can extract it with tar xzf and then the name of the file. That creates the directory tutorial Kazich. And if I move there and list the files, I see that I have a Qiime2 script, a database for classifying the representative sequences we'll eventually have, a sample data table, a script to run fastqc, and all of the raw sequences or data are in the raw seqs directory. Okay, I will clear the screen. I will need to source conda.sh to activate conda. I do it like this. Now I can list all of my environments with conda env list. And I see that I have one named fastqc. I can activate it with conda activate fastqc. We see the prompt changes here to indicate that I'm in the fastqc environment. And I listed the files here before. One of them is run fastqc. So if we take a look at that, so it defines an in directory and an out directory. If you've done everything the same way I have, you don't need to change these. They'll be fine. If you have put things in a different directory, you'll have to edit them. But what it does is for every file that ends with fastqc, it runs fastqc on that file, and it writes the results to out directory. After it's finished processing all of the fastqc files, it moves into that out directory and runs multiqc to produce a summary report for all of the files. So we can see here that it's already executable by the user. So I can run it just by, well, first telling the computer where it is, / and then run. So lines will scroll to the screen as fastqc is processing each sample. There are a total of 20. There's 10 samples, forward and reverse reads for each. It's finished, and now it's running multiqc to produce a summary report. So then we can go to our file manager, and we can look at those results in a browser. So here they're in the fastqc folder. If I click on any one of them, so this is the forward reads for the first sample. Then I get a report, like we've seen before. So the very first is basic statistics. It just tells you how many sequences you have, how long they were, etc. What we're really interested in is the per base sequence quality. And this shows you the average quality. This shows you statistics, these bar plots for quality for each position along the read from the beginning until the end. These are the forward reads. They look very good. The other thing we're interested in is whether or not there are any uncalled positions. It doesn't look like there are. And then the other thing we're really interested in is the adapter content. And it looks like there are no adapters present in this. So that's very good too. We can go back and look at the reverse reads for the same sample. We see that as typical, the sequence quality falls off more towards the end of these reads. But again, there are no ends and there are no adapters. We can go to the multi-QC report, select it, and we get a compilation of all of the reports for all of our sequences. What's most interesting, what's most pertinent here, we can go to status checks. And this summarizes everything. So we see that the per base sequence quality passes for all 10 of our samples. And also that, they're all the same length. There are no uncalled bases and then no adapters present. So these are very good results, and we're ready to go to the next step. So the next thing I want to do is to run Figaro. And so first I have to deactivate this environment. And then I can activate Figaro. Figaro has to be run from the directory in which it is installed. So we go back to Home, and then Figaro Master, Figaro. We can see the main program Figaro.py listed here. And so the command will be first Python, and then Figaro.py. We have to give the input directory with an I, -I. This is where the sequences are. So they are in tutorial Cossack, raw seeks. And we have to give an output directory. So we will make that just tutorial Cossack. And then we have to give the primer length. Well, there are no primers, but 0 is not an acceptable value. So we will, for F, for the forward primer, we'll say 1, and for the reverse primer, we'll say 1. And then we have to give the expected amplicon length, which is 253 base pairs. And the format for the file names is Illumina. So we run. Figaro has already determined that the reads are 250 base pairs long. This will take, usually takes about a minute and a half to finish. When it does, results will scroll up the screen. And there'll also be some files saved to the output directory. Okay, so it's finished. Here are the results. We can scroll back up the screen. So Figaro figures out where to truncate the reads. It assigns each combination a score, and then it presents the results in decreasing score values. The best truncation parameters are near the top of this report. So truncate the forward reads at position 99, the reverse reads at position 176. If we do that, then we expect one error in the forward read and 2 errors in the reverse read. And we should be able to merge 95% of all the reads. It's a very high percentage. So these are the values that we will use with Qiime2 when we process the data in Qiime2. So we can go back to the tutorial Qiime directory. And we see there's some additional files here. One of them is this trim parameters.json file. If we look at that, it presents the same information we saw at the top of that section of the screen. So you don't have to worry about losing these values if you close your terminal or something. They're still here. So you can go back and get them there. So there's one other thing to notice. When I listed all the files in the tutorial Qiime directory before, there are 2 ping files, figure files. So let's take a look at those. These are displays of the observed and predicted errors at each position in the read. So we see our agreement is very good, that the observed is almost exactly the same as they predicted. So this has to do with how Qiime2 works. Qiime2 tries to predict the expected number of errors at each position and correct them. So what this means, because the fit's so good, is we can have high confidence that using the trimming parameters we determine with Figaro, Qiime2 is going to do a very good job of correcting sequencing errors. Well, now we have our trim parameters to use with Qiime2. There's one more thing we need to do before we can start processing our sequences. If we look at the beginning of our Qiime script, we're going to use a manifest file to import the sequences. The manifest file associates sample names with the forward and reverse reads. It also gives the path to the reads. So we need to construct that manifest file. The way I do it is I go to the directory where the reads are. If I list all of them, if I just list them, I get forward and reverse. I want to list just the forward reads. So I can do ls and use the asterisk for wildcard, underscore r1 underscore asterisk, and that lists just the forward reads with r1 in the file name. So I'm going to pipe that to manifest file.tsv. And if I look at it now, I have just the forward reads in one file per line. So we'll open that file. Here I have all of the forward files. First thing I will do is to insert some more columns. And the first 3 or 4 characters are the file names or the sample names, so I can extract those, the function left, give it the first cell and 4 characters, and then copy that all the way down. We'll see that some of them have trailing underscores. So I will copy them and I will paste values. So now they're not formula anymore. So now I can go over here and do find and select, replace, and I will replace the underscores with nothing. So I made 3 replacements. And if I look at these now, there are no trailing underscores. Okay, so that's in column F. I will copy them all and put them in column G. And then I will take these, do find and select, replace, and I will replace the underscore or 1 underscore with underscore or 2 underscore. So all 10 were replaced. Now I have all the forward reads and the reverse reads. So now what I need to do is put the path to the files. I will use the variable home for my home directory. And then I will put the directory tutorial. Kazich. / raw seeks / Then I can copy that all the way down. Then I can concatenate the path with the file. So E with F, and in the C column, concatenate E with G. Copy those all the way down. Do a copy again and paste values. Let's reformat these so we can see them better. So now I have the sample ID in the first column, the path and the forward reads in the second, the path and the reverse reads in the third. And none of these are values none of these are formula anymore, so I can get rid of these. Now I need to insert a header line, so I add a row here. And the first one is going to be sample-ID. And the second one is going to be forward absolute file path file path. And reverse absolute file path. And check that you don't make any spelling mistakes, typos, because If you do, it won't work. Okay, looks good. So now I will save that. And but because I'm using Windows, these are going to have Windows line endings when I save them. And I can demonstrate that by opening the file again with Notepad++, and it will show that I have Windows line endings down here. Now, there's two ways I can solve this problem. If I have Notepad++, I can do edit into line conversion, change it to Unix, same as Linux line endings. And now it shows down here Unix line feed. I don't need to do that. I can leave them as Windows. Close it without saving. So if I go back to the terminal and use the stream editor sed, I can replace -is, make changes in place, and I can substitute \r for nothing in the manifest file. So I can go back and open the file again with Notepad++, and now I see that it has Unix line endings. So two different ways of changing line endings from Windows to Linux. Then the last thing to do is to move the manifest file up into the tutorial Qiime directory. So we can do that with mv manifest file // So now we see it's in the tutorial Qiime directory. And we're ready to start processing our sequences.